In this video, I'll discuss about power series. So first let us know why we need power series. See, power series are easy to manipulate and understand than the general functions. See, for example, many functions can be approximated by a power series in terms of polynomials. Power series is like a polynomial with infinite degree. See, for example, sine function, cos function, or the exponential function, these transcendental functions can be equated to a polynomial function to make some simplifications easier. So, dealing with the functions e power x becomes same as dealing with this polynomial 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. So it is an infinite series of terms and it is a polynomial of infinite degree, you can say. Say for example, this is the graph of y equal to e to the power x. So when you have the first term, that is y equal to 1, then it is a line parallel to x-axis. It can't be the approximation to this function. When you consider two terms, y equal to 1 plus x, then this is the graph of the function. So three terms, y equal to 1 plus x square by 2 factorial, which is 2. This is the graph of the function. See, compare it to the first term, second two terms, and here three terms. This is getting better approximation than this first one. Now see here, when you increase the number of terms, then you will get a closer approximation to the given function. Compare it to this first approximation. Here, as you go on with more and more terms, graph is becoming a closer approximation to the function y equal to e power x. Therefore, when you continue like this for an infinite terms, this polynomial becomes closely equal to the function e to the power x. So this is the importance of the power series. Consider one more example. I will consider the function y equal to sine x divided by x. So we know the infinite series expansion of this sin x in terms of polynomial. When I want the sin x by x function in terms of a polynomial, then keep 1 by x outside, then substitute the value of sin x in terms of infinite series. Simplify this, x cancels here, 1 minus, then x square by 3 factorial plus x power 4 by 5 factorial minus x power 6 by 7 factorial plus so on, because there is x in the denominator, one of the x cancels from the numerator. Now we know that limit x tends to 0, sin x by x is equal to 1. Therefore, using the expression for sin x by x in terms of polynomials, this limit can be evaluated more easily. You see here, limit x tends to 0, sin x by x is nothing but this polynomial. So when you apply the limit x tends to 0, this gives you 1 minus 0 by any value, it is 0. Therefore, all these terms will vanish, that is equal to 1. So this is the importance of using power series. Having said the need of power series, now I'll define mathematically power series. A power series is an infinite series of the form summation n equal to 0 to infinity an into x minus c to the power n, which is nothing but when you go on giving the value for n, we'll get the expansion as a naught plus a1 into x minus c plus a2 into x minus c whole square plus so on, where an, it is a coefficient of the nth term, and c is a constant, and c is called as center of the series. So you have to remember the standard form of a power series. It's an infinite series and an are the coefficients, c is the center of the series. Therefore, what is the center of the series? Center of the series is any constant value c such that the series has infinite terms in powers of x minus c. So the series is expanded in terms of x minus c if c is the center. You can take any value, any constant value as a center. So if you have taken that constant value c as the center, then the expansion will be in terms of x minus c. Say for example, if the center c is at the origin, that is 0, then the expansion in terms of x. If the center is at the point c equal to 1, expansion of the power series in terms of x minus 1, and so on. So this is what the meaning of center of the series. Now, whenever any series is considered, we always look at the convergence of that series. Convergence means, is it going to some unique and particular value? Then we say that the given series converges. And in this case, we need the interval of convergence also. Interval of convergence means it is interval of x values that can be plugged into the power series to give a convergent series. As it is the general term x, you can go on giving different values of, for x. Now, interval of convergence means it is the interval of x values that can be given to this so that it gives you a convergent power series. Such interval is called as interval of convergence. The power series always converges at its center. So we have said here x equal to c is the center of the power series. Now, this power series always converges at the center because at x equal to c, all these terms will become 0. The series will go to a naught, means it is a particular unique value, constant value. Hence, the power series converges always at the center. Other than the center, is there any value of x for which the power series becomes convergent? Then all such values collected together will give you the interval of convergence. Now let's see what is radius of convergence. So when you have the interval of convergence and center for the given series, then definitely there will be range until which the series will converge. So what is radius of convergence? For every power series, there exists non-negative real number, means it can be positive or zero, are such that R can be unique and finite, R can be equal to 0, and R can be equal to infinity. If R is unique and finite, then it is convergent for mod of x minus c less than R, divergent for mod of x minus c greater than R. If you get R equal to infinity, then it is convergent for all x. If you get R equal to 0, the series is convergent only at the center x equal to c. Now, what is the formula to find the radius of convergence? This is by the ratio test. We have r equal to limit n tends to infinity modulus of an by an plus 1. So, this is the formula. Or else you can remember it as 1 by limit n tends to infinity modulus of an plus 1 by an. Or else, one more way to represent the radius of convergence is r equal to 1 by limit n tends to infinity modulus of an to the power 1 by n. This is because by the Cauchy's second theorem on limits, this value must be equal to modulus of an to the power 1 by n. From that, instead of calculating this, we can calculate the radius of convergence using this formula as well. This formula is helpful when you have nth term in terms of power of n. Now let us take some examples to understand the concept of radius of convergence, interval of convergence. Find the radius of convergence of this power series. So first, you have to compare this with the standard form of the power series n equal to 0 to infinity a n x to the power n. This is the standard form of a power series, or x minus c to the power n. Here center c is at 0 and an is, there is no term here, it is constant, which is equal to 1. Let us find out the radius of convergence, limit n tends to infinity, modulus of an by an plus 1, which gives you limit n tends to infinity 1 by 1, that is equal to 1. So we got radius of convergence, finite and unique value. Therefore, we have to make use of that first point. The series converges for mod of x minus c less than r and diverges for mod of x minus c greater than r. C is 0 here. Therefore, series converges for mod x less than 1 and diverges for mod x greater than 1. Equal to 1, mod x less than 1 means x is greater than minus 1 and less than 1. That is the interval. But at end points of that interval, like at x equal to minus 1 and at x equal to 1, what happens to the series? That we have to check separately. Because now from this we can get the interval of convergence as minus 1 to 1, open interval. But end points are not verified here in this. So you have to verify it separately. At end points, let us calculate x equal to minus 1, x equal to 1. At x equal to minus 1, the series becomes minus 1 power 0 plus minus 1 power 1 minus 1 power 2 minus 1 whole cube plus so on. So that gives you 1 minus 1, 1 minus 1. So it has different values. So when n is even, like up to n equal to 2, if you take minus 1 plus 1 cancels, you will get the value of 1. N is even. When n is odd, all the terms will cancel, therefore you will get 0. It has two different values. For x equal to minus 1, this is the sequence of partial sums. This is the given series. The given series converges if the sequence of partial sums converges. The sequence of partial sums nth term is 1 when n is even and 0 when n is odd. Therefore, as n tends to infinity, it is giving you two different values. If it is convergent, it should converge to a unique and finite value. But here it is converging to two different values. Therefore, this sequence oscillates, sequence of partial sums oscillates. Anyway, we want is it convergent or not? It is not convergent. Therefore, this series also not convergent. Now consider when x equal to 1, 1 to the power 0 plus 1 to the power 1, 1 square plus 1 cube, 1 repeats in finite terms. Therefore, for x equal to 1, Sn, the sequence of partial sums is equal to n. Nth term of sequence of partial sums is equal to n. So, the series converges if the sequence of partial sums converges. So find out limit of Sn as n tends to infinity, which goes to infinity. Main sequence of partial sums divergent, therefore the series is also divergent. Therefore, at x equal to minus 1 and 1 end points, the series divergent. It converges only for mod x less than 1, hence the interval of convergence is minus 1, comma 1. This is how we find the interval of convergence. So to find the interval of convergence, we always need the radius of convergence. Now consider one more problem. Find the radius of convergence of this series. Compare this with the standard form of a power series. Here center equal to again 0, an is equal to 1 by n factorial. So first let us find out the radius of convergence using the formula limit n tends to infinity modulus of an by an plus 1, which gives you limit n tends to infinity 1 by n factorial by 1 by n plus 1 factorial. You can split this n plus 1 factorial as n plus 1 into n factorial. So cancels, you will get n plus 1, apply the limit, you will get it as infinity. So when the radius of convergence is infinity, that means the series converges for all real numbers, for all values of x. Hence, the interval of convergence is all real numbers. You can represent them as open interval minus infinity to infinity. Third problem, find the radius of convergence of summation n equal to 1 to infinity n factorial into x to the power n. So here an equal to n factorial and center c equal to 0. Therefore, let us find out the radius of convergence using the formula r equal to limit n tends to infinity modulus of an divided by an plus 1. So an is n factorial, hence an plus 1 is n plus 1 factorial. Now n plus 1 factorial can be splitted as n plus 1 into n factorial. So n factorial cancels. So when you apply the limit, you will get as n tends to infinity, this value becomes 1 by infinity, which is nothing but 0. When radius of convergence is equal to 0, means the series converges only at the center. Here center c equal to 0. Therefore, the series converges only at x equal to 0. Now fourth problem, find the radius of convergence of this power series. So first compare this with the standard form of power series. I have taken almost all power series with the center at 0. Here an equal to minus 1 power n by n plus 1 and c equal to 0. Find out the radius of convergence using this formula. Substitute here minus 1 power n by n plus 1 into minus 1 power n plus 1. This goes to the numerator, n plus 2 goes to the numerator. You can simplify this as there is modulus minus 1 power n cancels, 1 minus remains. I have kept it outside. N plus 2 divided by n plus 1. So now when you take n common, cancels, minus of 1 plus 2 by n divided by 1 plus 1 by n. So as there is modulus, minus goes. When you apply the limit, it gives you 1. Therefore, the series is convergent. It is unique and finite value. Therefore, the series is convergent for all x mod of x less than 1 and diverges for mod x greater than 1. So, the interval of convergence can be open interval minus 1 comma 1. But now you have to check separately for the end points x equal to minus 1 and x equal to 1. What happens at the end points? How the series behaves. See, for that, at x equal to 1, the series becomes minus 1 power n by n plus 1. So, when you go on giving the values, you will get this series, alternating series it is. So, by Leibniz test for alternating series, that alternating series converges if limit of an as n tends to infinity equal to 0 and an is greater than an plus 1 for all n. If this condition satisfies, then the series converges. Let us check that condition for this series. Here nth term is 1 by n plus 1. So limit of an as n tends to infinity is 1 by n plus 1, which is equal to 1 by infinity gives you 0. So this condition is satisfied. And an is greater than an plus 1 clearly, because n is less than n plus 1, but 1 by n is greater than 1 by n plus 1. It's reciprocal. Therefore, an is greater than an plus 1. Both the conditions are satisfied means the series is convergent. Therefore, at end point x equal to 1, the series converges. Now, there is another endpoint, that is x equal to minus 1. Let us see what happens to the series. So, series becomes n equal to 0 to infinity minus 1 power n into minus 1 power n, because x is x to the power n given in the question. So, it is x equal to minus 1 power n by n plus 1. So, it is minus 1 power 2n by n plus 1. It is even, therefore, it is 1 by n plus 1. So as n starts from 0 to infinity, this is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on. So now this series using the p test, summation of 1 by n to the power p diverges if p less than or equal to 1 and converges if p is greater than 1. Now in this case, n plus 1 to the power is 1. So p is equal to 1. Therefore, this series clearly diverges. So at x equal to minus 1, the series diverges. At x equal to 1, the series converges. Therefore, only one of the end point is included in the interval of convergence. Hence, we will get interval of convergence as minus 1, comma 1, closed interval. This is closed. Here it is open. Find the radius of convergence of this series. See here, center is 0 and an is n to the power n. I told you there are two ways of finding radius of convergence. One is using this ratio or else using this formula, r equal to 1 by limit n tends to infinity an to the power 1 by n. So now in this case, I will make use of the second formula because simplification becomes easier here. So this is equal to 1 by limit n tends to infinity. An is n to the power, modulus of n to the power n to the power 1 by n. So this power cancels. So we will get as n tends to infinity of n, so it is infinity 1 by infinity, which is equal to 0. Therefore radius of convergence is equal to 0. Hence it converges only at the center, and center of the series is c equal to 0. Therefore the series converges at x equal to 0 only at the center. Find the radius of convergence as well as the interval of convergence for this series. Now in this series, the center of the series is c equal to minus 1. It is other than 0 now. X minus c to the power n. So x minus of minus 1 to the power n you can write. So c equal to minus 1. So center c equal to minus 1. An the coefficient an is n by 4 to the power n. So find the radius of convergence as n tends to infinity an by an plus 1. So that is n by 4 to the power n. So divided by an plus 1. So this term comes to the numerator divided by n plus 1. So 4n cancels, 1 4 remains in the numerator, 4n divided by n plus 1. So n also cancels when you take common. The answer is 4 after applying the limit. Therefore, now it is a unique and finite value. It converges for mod of x minus c less than r, diverges for mod of x minus c greater than r. Therefore, the series is convergent for mod of x minus c. In the place of x minus c, we have x plus 1. So less than 4 means x plus 1 belongs to the interval minus 4 comma 4. That is the property of mod x less than a means x belongs to open interval minus a comma a. So x plus 1 belongs to the open interval minus 4 comma 4. So x belongs to, subtracting minus 1 from both the end points, minus 4 minus 1 minus 5, 4 minus 1 3. So x belongs to this open interval. Now we have to separately check at the end points x equal to minus 5 and x equal to 3 to make sure the interval of convergence is open interval minus 5 comma 3. So at x equal to minus 5, put x equal to minus 5 plus 1 minus 4 to the power n. So 4 to the power n cancels, you will get minus 1 to the power n into n. You can look at this series. This series clearly it diverges. Similarly, when x equal to 3, the series becomes 3 plus 1, 4 to the power n. N by 4 power n into 4 power n cancels summation of n equal to 1 to infinity, which is n. Clearly, this series also diverges. You can check with the sequence of partial sums. This series clearly diverges. Hence, endpoints are not included in the convergence. Interval of convergence is open interval minus 5 comma 3. So this is how we define power series, then center of power series, radius of convergence, and finding interval of convergence of a power series. I hope you understood the concept. Thank you for watching.